let's talk about the pulp and paper industry. If you're looking at this sector, you are looking at an incredibly water-intensive business. I mean, just think about it for a second. The sheer volume of water required for processing materials alone is absolutely staggering. And then you add in process cooling, plus the massive steam generation needed at their on-site energy plants, you quickly realize that water isn't just some minor operational detail, it is literally a critical lifeline for these facilities. Because of this massive demand, securing a stable water supply and properly managing the wastewater that comes out the other side is a top priority for long-term sustainability. So, today we're going to break down exactly how to audit and report these water risks using the strict guidelines of the SASB standard. Let's dive in. Here is our roadmap for today's walkthrough. First, we're going to define the water mandate under the standard. Then, we'll compare withdrawn versus consumed water. Third, we'll look at mapping baseline water stress. And finally, we will wrap up by documenting mitigation strategies.
All right, part 1, defining the water mandate, specifically looking at SASB water management metrics.
So, long-term sustainability in the pulp and paper sector requires a really precise, highly structured framework to manage all those massive water inputs and outputs. Under the SASB framework, the required data is actually separated into two very distinct reporting metrics. First, you have RRPP 140A.1, which is purely quantitative. This is where you are reporting the hard numbers. We're talking thousands of cubic meters of water and strict percentages. But right alongside that, you have RRPP 140A.2, which falls into the discussion and analysis category. This requires a narrative description. You have to explain your water management risks and the actual on-the-ground practices used to mitigate them. To do a proper audit, you absolutely need both, the hard math and the strategic context.
Moving right along to Section 2, withdrawn versus consumed water. Let's break down these metrics.
The standard requires a very strict separation between the water a facility takes in and the water it actually uses up. Total water withdrawn refers to water pulled from all sources. So this includes surface water like rivers, lakes, and oceans. It includes groundwater, any rainwater that the facility collects and stores directly, and of course municipal water and wastewater utilities. Now, total water consumed, on the other hand, is a much narrower metric. It requires a highly specific calculation of what does not go back into the local environment, which we're going to break down in just a second. But before we calculate consumption, we have to talk about fresh water. If a facility pulls in a lot of non-fresh water, they do have the option to disclose their supply by source. But here's a question. How do you officially define fresh water if your local laws and regulations don't actually have a set definition? Well, the SASB standard gives us a really interesting, hyper-specific benchmark. If no legal definition exists, fresh water is strictly defined as water containing less than 1,000 parts per million of dissolved solids. Oh, and just a quick side note. If you get your water from a municipal utility that complies with drinking water regulations, you can just automatically assume it meets this definition.
Okay, so the crucial point here is how we actually calculate consumption. You start with your total withdrawal, but then you have to categorize it. Under the standard, water consumption strictly includes three things. First, and this is a big one, water that evaporates during withdrawal, use, and discharge. In an industry that is so heavily reliant on steam generation and cooling, evaporation is massive, and yes, it counts as consumed. Second, water that is directly or indirectly incorporated into the actual paper or pulp product. And third, water that does not return to the same catchment area from which it was withdrawn. Think about it. If you withdraw water from one river and discharge it into the ocean, or just a different catchment entirely, that is officially classified as consumed.
Section 3. Mapping baseline water stress. This is where we get into geographic risk auditing.
You see, you don't just report your total water use in a vacuum. You have to report exactly where that water is being used. To satisfy the standard, entities have to analyze all of their operations using a very specific tool, the World Resources Institute's Water Risk Atlas tool, which is commonly known as Aqueduct. Basically, you run your operational locations through this tool, isolate the regions facing specific levels of baseline water stress, and then you calculate exactly what percentage of your total withdrawn and consumed water is happening in those fragile, stressed areas.
When you're using the WRI Aqueduct tool, auditors need to look for two specific thresholds. The first is high baseline water stress. The tool defines this as regions where the stress levels sit between 40 and 80%. If a pulp mill is operating in one of these zones, every single drop they withdraw or consume there gets flagged, and it has to be calculated into this specific high-risk percentage bucket for their final disclosure. Then, at the very top end of the risk spectrum, you have the greater than 80% threshold. This is officially classified as extremely high baseline water stress. It is absolutely vital that the audience, whether we're talking about investors or regulators, knows the exact percentage of an entity's withdrawn and consumed water that originates from these critically stressed regions. Because water scarcity in these zones isn't just an environmental issue, right? It translates directly to much higher supply costs, severe supply disruptions, and honestly pretty intense tension with the local communities.
Which brings us to our final section, Section 4, Documenting Mitigation Strategies under RRPP 140A 2.2. Okay, so we've done the math, now we need the narrative. Entities must formally describe the intense, multifaceted risks associated with their water withdrawals and wastewater discharges. And to be clear, this can't just be a vague summary. The standard requires discussing environmental constraints, like operating in those stressed regions we just mapped out, dealing with droughts, and the overarching impacts of climate change. You have to detail your regulatory and financial constraints, things like the volatility in water costs, sudden restrictions to withdrawals, and your long-term ability to even retain your water rights. Plus, you have to address the reputational side, specifically stakeholder perceptions and concerns from local communities and NGOs regarding how much water you withdraw and what your discharges actually look like. But you can't just list your risks. You must detail your short and long-term mitigation strategies to fix them. The standard asks for specific operational targets. For instance, are you implementing efficiency efforts like closed-loop systems or advanced water recycling? What about process and equipment innovations? A really great example cited in the standard is upgrading equipment to reduce aquatic impingements or entrainments. That's basically a fancy way of saying you're making sure aquatic life isn't getting caught up in your facility's intake systems. And finally, they want to see if you have active collaborations or programs in place with the local community to manage these shared water resources together. Now, you don't have to guess how to build these strategies. To analyze your water use, risks, and opportunities, the standard explicitly points entities towards several international analytical tools. We already mentioned the WRI Aqueduct for mapping the stress levels, but for broader mitigation and risk analysis, acceptable tools include the World Wildlife Fund Water Risk Filter, the Global Water Tool, and the Water Footprint Network Assessment Tool. Using these recognized tools adds a ton of validity to the mitigation strategies you're reporting. I want to leave you with one final, totally fascinating requirement from the standard that really bridges the gap between mere compliance and true, holistic environmental stewardship. When you report your water management practices, you must also discuss whether those practices result in any additional life cycle trade-offs. So think about this. Building a massive, highly advanced water recycling facility might drastically reduce your total water consumption, which is great. But what if running that facility requires so much electricity that your greenhouse gas emissions completely skyrocket? Are your water mitigation strategies inadvertently increasing your carbon footprint? The standard demands that you report these trade-offs and explain exactly why you chose your practices despite them. It's a brilliant reminder that in sustainability, every single action has a reaction. Thanks for joining me on this explainer.